Okay, so last class we ended with the sine function, so let's start with it today. So our sine function, the part we drew at least. So there's my y-axis, there's my x-axis, okay? And we said, well, sine of 0 is 0. And you can type that in if you want. So 0 degrees is 0. Sine of 180, type it in, that's 0. Sine of 360, well, those values were all 0. So there's at 0, there's at 180, there's at 360. Okay, and then if we split that in half here, let's see at 90 degrees. Oops, that's a degree sign. So at 90 degrees, we end up with a value of 1. So sine of 90, type it in, equals 1. And split these guys in half, so at 270 degrees, I get a sine value of -1. So my curve connects my maximum to my 0, and my 0 to my minimum, all the way up. And yeah, that's not really to scale, but that's okay, gets the point across. So my maximum is equal to 1. My minimum is equal to -1. My amplitude is equal to 1, because that's from the middle line up to the top. Amplitude is also here, middle line down at the bottom. So my midline is my axis of equilibrium. Okay, sine curve repeats itself every 360 degrees. So our period is 360 degrees. And it goes forever and ever and ever and ever and ever and ever and ever and ever. So my sine curve really, like we're just kind of focusing on a key piece here. It really goes forever and ever and ever and ever and ever and ever and ever. So that means that my domain is for x is any real number, so for any angle. My range, however, is restricted because my sine values will always be between -1 and +1. Okay, so my range is restricted. We're going to start playing with this a little bit more, but my base function, that's what it looks like. Okay, so today what we want to look at is we want to kind of take this and give it some context. So my context is going to come in the form of this video. So here I have, oops, let's put it back to the start. So here's somebody put together in Geometry Sketchpad. I think this is Geometry Sketchpad. A Ferris wheel. So here I've got different passengers. I have a red person is sitting here, and that's what my dots are showing is the height above the ground. So there's my maximum height. Notice how it comes back down. It goes through the middle, comes back down. It hits the lowest point, comes back up, goes through your middle point, goes back up. There's my maximum. So notice how the height of the passenger is a sinusoidal function over time. So there's my height, there's my time. We're going to work with this. And this is what we're going to focus on today. Sound good? So I just took a screenshot of what we saw, and let's kind of draw some things on here. So our x-axis is time. Our y-axis is our height above the ground. Height above ground. Okay. And notice that our maximum height goes from the top of the Ferris wheel across. So there's our maximum height. And then we can draw a line from the bottom of the Ferris wheel across. So there we would have our minimum height. Notice how it's off the ground, right? So there is a distance off the ground. Off the ground, right? Because the passenger gets, they're not on the ground, they just smash into the ground. Okay, we've got another line here that let's make sure we draw. And this line is very important because it's the middle line. So that's where I would find my axis of symmetry. Because that's the radius, or sorry, where the center of my Ferris wheel is. Okay, so my axis in this scenario is the center of the Ferris wheel. Okay, so that's where it is off the ground, and I can still find it using my skills that I found yesterday. So that's still going to be where my maximum plus my minimum divided by 2, okay, is still going to be there. My amplitude, well, that's just the radius of my Ferris wheel. So there's my amplitude. There's another amplitude. So my amplitude is the radius of the Ferris wheel. Okay, and the amount of time it takes to go from the bottom back to the bottom, or from the top back to the top, well, that's going to be the length of one cycle, which we call the period. So one cycle, I'm just going to go from peak to peak because it's easier to draw up here. So the period is the time for one loop around, whatever you want to call it. That's our cycle. Time for one cycle. So before we move on, let's just make sure this page has everything. So our amplitude, remember, is going to be our maximum minus our minimum height divided by 2. Axis, we added them. Amplitude, we subtract them. And to find these things, we're going to have to look for that radius in the question. That's often going to be a really good clue. So let's do some questions and do some interpreting and see how it goes. All right, so let's take some stuff from your textbook here. So this is from page 344. Okay, so here we have at an amusement park. The math teacher had different students ride 2 Ferris wheels. Thomas rode on Ferris wheel A and Ryan rode on Ferris wheel B. The teacher collected some data and produced 2 different graphs. So what we want to do is we want to analyze this. So clearly, they're different wheels. So what's so different about them? Let's read some values and see what we can figure out. So can we figure out where the bottom is? Where's the bottom? So that would be at our minimum. So our minimum would be here at 1. So the minimum height is at 1. Is at 1. So let's look over here. Where's our minimum? So there's our minimum there. And again, so they both have a minimum height of 1. How about our maximum? Let's see here. Our maximum seems to be at 7 for this one. So that's our max. How about over here? Oh, our max is, oh, this one's much taller. So the max is up at, I would read that at 13. So they definitely have 2 different values for maximum, which means our amplitudes are going to be different. So let's figure out our amplitude. So that will be max minus our min divided by 2. So 13 minus 1 divided by 2 gives me 12 over 2, so 6. So I have an amplitude of 6 on this one. How about over here? Amplitude is max minus min divided by 2. So my maximum's at 7, my minimum's at 1. 6 over 2, so it has an amplitude of 3. So this one's, you know, a lot shorter. Okay, so in our Ferris wheel versions, that tells me that's the radius of the wheel, is my amplitude. So this one has half the radius of the other one. All right, what else can we know? Well, using our maximum and min values, well, we can figure out what the center of the wheel is, because it's definitely different in both of them, right? If the radius is different, the center has to be different. So for this one, let's see, our axis is going to be at max plus min divided by 2. So at 13 plus 1 divided by 2, that gives me 14 divided by 2, so that's at 7. So I can draw a line at, oh, it's already red, good, 7. So there's my axis. For my other one, again, let's calculate that one. So for here, my axis is max plus min divided by 2. So that gives me a 7 plus a 1. divided by 2, which gives me 8 over 2, which is 4. So that would mean I would draw its center line at 4. So that's where the middle of the wheel is. Okay, so if I were to draw my Ferris wheel here, so this guy, right? There's my ground. So his center is 7 meters off the ground. The bottom is at 1. The top is at 13. And it has a radius of 6. This one over here, if I draw the same picture, he's much shorter. So it still has a minimum of 1. This one had a maximum of 7. There's my radius. So my radius is at a height of 4. So it's 4 meters off the ground. And my amplitude, so the total radius, would be 3. Okay. Do we know anything else? How about the time it takes to get around? So the time of each ride. So the time for one cycle, remember that's our period. So for this one, so I'm starting here on the picture, I go up, I down, I come back. I go up, I down, and I come back. So 40. So one cycle goes from 0 to 40. 40 minus 0 is 40. So the period is 40 seconds. So it does one loop in 40 seconds. How about over here? Let's see. There's my 4, or sorry, there's where I start. Let's go across. Oh, 40. Up and down and, oh, 40. So they both have the same period. It's equal to 40 minus 0, which is 40. I could have done it from here to there. So that would have been at 80 minus 40. Still gives me 40. So that's pretty exciting. So that's basically what I want you guys to do today, is I want you to analyze some graphs. So good luck, have fun, and I'm here for your questions.